Okay, great. So, hi everyone. Thanks for being here. As always, this is RSM Core Deep Dive number 2, and I think with today we should be able to cover most of what we need for now, at least. We are going to pick it up basically just what at the point that we left it last week, but I think it's better to start pausing a little bit and just reflecting and thinking about last week and what things we have clear and what things we don't understand yet, because this is a concepts building on top of other concepts, right? So let's do a check-in. How much of last week's discussion do you think you have more or less clear? This is everything and this is nothing. Well, that's pretty good. That's much more than I expected. That's awesome. Okay, so what are pain points or things that any of you have any questions around? Like, what we are going to do is drill a little bit down into more detail about the different things that we only saw on an overview of last week. So in the general sense, what are things that are bugging you? If there are any.
I think I would like to know more about workflows in detail because that didn't stick with me last time. But the part where the DHT ops were being explained, that was pretty clear to me.
Okay. Okay, I think that's good because like today we are going to cover basically all the workflows that are in a holochain cell, not in a lot of detail, but just so you get a big picture of all the life cycle of a cell, and then we are going to go a little bit from there and see what we can explore. Okay, so let me share my screen. Okay, so can you see my screen well?
Yep.
Okay, great. So yeah, last week we saw that basically one of the fundamental concepts that we need to know in order to understand how the core works, and not only that, understand also how to design applications in holochain are DHT ops, and actually a lot of the workflows that you see here in a cell are oriented towards producing, receiving, and storing DHT ops, as well as the source chain stuff. So like all the simplifications we do when we explain holochain is that holochain has this private space which is the source chain, and this public space which is the DHT. So here we have this both with a lot of added pieces of data and state to be able to maintain those. So I want to go over the workflows in kind of a application life cycle. So first I install an application, what happens, then I call some function, what happens, then some other node receives those DHT ops, what happens, and so on. Interrupt me as much as possible so that we can get detail on where we need to, and not so much where we don't need. So okay, let's start then. If we think about the life cycle of a cell, first thing you do is installing the cell. So installing the cell will create all the databases for us. Okay, so just remember, this is not everything that is in holochain. This is just a picture of the cell, right? So an instance of a DNA running. So question. Oh no, okay, sorry, it was background noise. So yeah, after installing the application, the workflow that's called is the Genesis workflow. We touched a little bit on this last week, but the Genesis workflow is very important. It's a workflow that doesn't invoke any application of our code. So this is going to run the same for every application, but the entries that are going to be generated are going to be different for every application. So the entries generated in this Genesis workflow, the Genesis workflow is a very simple workflow, actually. And what it does, it basically initializes your source chain, creating these 4 entries. No, okay, sorry, creating these 4 headers, okay? So it creates the DNA header, the agent public key header, the membrane proof header, and the capability grants header. So these 4 headers you will find in any source chain of any holochain application. And this is done first as a matter of security. So if you have the DNA hash in the header, you can make someone accountable. So that they have promised that they are running the DNA with this hash. The agent public key is a very important one because, like as all of you know, in Holochain, we are linking from and to agent public keys all the time to say, for example, link the posts from an agent public key to get all the posts for that agent public key. And this is where this gets committed. The membrane proof is one new feature of RSM in which when you call install application, you can send an arbitrary payload that's called the membrane proof. And the function of that is being able to validate whether an agent is valid or not in that membrane, taking into account the content of the membrane proof. So, okay, imagine that we have a membrane in which only people with a certain password can enter. So the password will be entered with a membrane proof. This is a simple example because all the agents are going to have the same passwords, but you can think of more sophisticated membrane proofs like vouchers in social triangulation or tickets in Lib. So this is where these kinds of things are stored. And it's important to know that this membrane proof is not visible either with the DNA or in the DHT before the agent has joined. So, for example, you can say only the people that commit this password as membrane proof can enter, and this is secure because the password won't be stored in the DNA file. Because, for example, you can say in the DNA, make sure that the hash of this password is equal to this hash. So the hash, the password itself is not stored on the DNA, and the person cannot go on the DHT and look at the membrane proof or whatever because they still haven't joined the DHT. And this is important to know. Only like every time a holochain node tries to establish connection with another one, they are going to try to validate it. And if they can't validate it, the connection won't be established, basically.
Given a membrane proof, we can inject during the cloning the DNA. In that phases, when we are cloning, we need to inject this data.
Yeah, not only cloning, but more general installing.
General installing.
Yeah. Cloning is a special case of an install application. So, but yes, that's good. Okay.
Guillem, sorry, I have another question. So if agent installs DNA and then their membrane proof is not valid, then it means that they would still be running this DNA, but they would not be able to join any existing networks because this header would be validated by any node they are trying to connect to.
Okay. That's right. So Yes, and it doesn't, like, the fact that they are running that DNA in their own computer, you cannot do too much about that. But any connection, yes, it's going to be rejected.
Okay, cool. Thank you.
Cool. Okay, and
yeah, sorry, one more question. If an agent if an agent had an invalid membrane proof, can he try to get a correct one and then get revalidated again by other agents?
That's actually a good question. I don't know the answer to that, but my assumption is that no. Like, when you're validating an agent, okay, let me think this through. Okay, what the agent, what the agent could do is try to install the application with a new public key, for example. So generate a new public key. Now they are a new agent. Now they can enter a new membrane proof, and the other nodes are going to try to validate the agent again because they have no idea it's the same person. You know.
I see. Okay.
But this mechanism of validating the membrane proof and the agent works. It's like a special case of a validation rule, but it works the same as a validation rule. So it has to be deterministic. When the validation rule fails, there are warrants that are spread throughout the system, so that if that agent tries to come again, everyone is going to be like, no, we just validated you and you're not valid.
So it remembers the public key, which corresponds to every membrane proof. So if I drop all my data and reinstall the same DNA with the same public key, and my membrane proof is now a different entry, different header, then I would still not be able to join any network because other nodes have remembered my public key and invalid membrane proof from the last attempt.
Right. So what happens more detail is that you don't validate the membrane proof, you validate the agent. And this is what we had in Redux as well. You had a validate agent callback and you validate the agent. But the thing is that validate agent call now is going to receive the membrane proof as well as the agent. So you're going to be validating both the agent and membrane proof, or neither of them.
I see.
So yeah, that's basically it. And then if you think about it, the membrane proof it has a header, and that header carries with it the author of the public key, because all headers do. So like, you have this no matter what.
And Guillaume, another top. Go ahead, Nastat. Go.
Oh no, I just said okay. Sorry.
Guillaume, if it's not gonna be valid, so it means others node going to mark this user as invalid user, or warning actually. So it means still user going to put a pressure on network. Is that true? It means the user can install DNA, can continue, can communicate to others, sending operation, but others are gonna mark that user as a sender warrant.
Yes, but this is a special kind of warrant in which if you have this warrant, no one will ever even initiate communication with you. Like, you're not going to be able to do fast push here, for example. This you're not going to be able to do because people will just trap your connection.
Okay, and any workflow that sending the headers or operation, they are gonna be still working?
No, like in the computer of the bad agent, yes, because like it's their own code, it's their own machine, you cannot shut it down. But as soon as they try to reach another node, that node goes, okay, let me first verify that this agent is valid, and they see, oh, it's not, so drop.
So I'm not gonna open just another one. What if the proof is false, all the workflow of communication in a local can stop?
Yeah, but a bad agent, we are always assuming that a bad agent has forked its code. So they can do whatever they want in their code. We cannot stop them.
Thank you.
Good.
And okay. Sorry, one last quick question, Guillaume. And there's the only way for us to check if the payload of the membrane proof is correct is if we actually compare it with the hash that's in the DHT, right? So we can't check it pre-validation of the membrane proof.
I don't understand what we can't check.
Okay, so let's say we have a password in the membrane proof, right?
Okay.
And we want to check the hash of it with the hash that's stored in the DHT as something we compare with, right? So, so then there's no way for us to, because I'm thinking of like, okay, how can we allow like retry mechanism in this particular one? Because I'm worried about when you have another, your public key has another DNA running, which is kind of like a lobby, and you're creating small DNAs, basically cloning it.
Yeah.
If you can't get inside the cloned DNA, then you have to change your public key. It seems like that's the only way to do it now. So then your identity in the other DNAs will also get lost. You know.
Okay, get it. I think I get it, but wait just a minute. So you're talking about a retry installation with a good actor. So
yeah.
Okay, so the first thing that a good actor will do is try to validate the payload that is passed in the install app command, because they are running the good DNA. And if that validation doesn't pass, the app won't get installed, like altogether. And they will be able to retry because the application itself, like, it won't have worked. At least that's my assumption. I don't know this 100%, but this would make a lot of sense, you know.
Okay. So
just finish the installation process if actually the payload, if I'm valid. Like a good agent would behave like this. Just finish all the installation process. If me myself, I'm valid.
I see. Okay.
Another short one regarding to development. Should be able to query DHT in this phase?
You cannot query DHT if you have not been validated, because nodes won't even initiate connection with you.
That's great. So during the genesis for this proof, we cannot query DHT. Anything supposed to be should be a logic on the client, on the agent side.
But the thing is, Genesis, this doesn't call any code of your application. You cannot do anything here, at least yet. Maybe in the future we have an app install, but it seems unlikely. We already have init zones here.
How developers can understand putting query or something here is wrong? It's not going to be working. You receive error. Or...
No, the thing is you cannot do it. So you cannot write a piece of code that's executed before this.
That's it.
It doesn't exist.
Thank you.
Yeah, the first time that something can be executed is in the init, which is after Genesis in here. All good?
I have another question, sorry.
Go.
So if we are remembering all the invalid agents by their public keys, does it mean that network can be overloaded by, let's say, 10 millions of invalid agents? I mean, they would be consuming some storage, and every valid node would still be checking public key against these registry of invalid agents. So how would that impact performance?
That's a good question. I don't really know. Like we have to see. We have to see in a case of millions of users and some bad agents trying to get inside the network and so on. I don't know.
Okay.
All good? Awesome. Yep. So let's continue. So we have now run the Genesis and we have committed this for the capability grants. I didn't say too much about it, but it's quite important because this is what is saying, okay, this public key I'm holding, allow it to call any some function or anything like this is me. Okay. I'm assuming you already know about capability grants. If not, you just say so. Okay, so that's the Genesis workflow. Remember, in here, no code of our application is executed. Then we go to Initialize Zones, which in RSM is a little different than in Redux because this is the init function. So in Redux, we have the init callback, but init would be called on app installation in the order that you defined breaches in the old version. That's a little convoluted, but I don't want to get fixed into the previous version. This one, the init of the zones is going to be run when the first zone function is called, and this has not been run yet. So if you really want to do it just before the installation, maybe from the UI, you can just call some who am I function, or something like that, to actually trigger the init of the zones. This is how it is right now. Maybe in the future, it will be different. So this is this init function is something that you have to, like, after being validated by the network, you want to, for example, create some anchors, create some, I don't know, some profile that you got from somewhere else, but like, I don't want to, this has not very much to it. It basically calls the some function of your DNA and executes whatever.
Is there any data passing through it as an argument?
Nope.
No. Can we query DHT?
Yes, because you already have been validated.
Validated. So this one is just calling for the user. Other validators are not calling this one. It is just for the agent.
Exactly. Yeah.
Yes. And the last one, is there any changes about the Genesis entry in RSM, or it is exactly like it before? The Genesis entry that creating at the first step, at the local chain.
Yes, these four are different. Like, at least these two are really different. In the previous version, these two with like they would get created, yes. But this for sure not, and capability grants maybe in latest version, but I don't think so.
It means 1, 2, 3 entry, one header. It is generally 4 entry.
No, this is a header. This is a header. I don't know if this is a header or not. I think it's a header also. And this is an entry.
This is an entry.
Plus header. Like at all times there is an entry. There is a header always, but not the other way around. Not everywhere there is a header. There is an entry.
Thank you.
Okay, cool. So now we have our application installed. It's running, and now let's say that from the UI we call some function. Right, so this call zone function, first thing it does is it goes to our application code, searches for the function that you want to call, and just executes it. And we are going to, let's see if we have time, we are going to see a little bit in more detail how that is done. Okay, so let's assume that we have executed our some function with all the application code that might have been executing and so on. So maybe some gets, some commits, and so on. Okay, no, I have to explain something else first. Okay, so I want to focus first before going further in what happens when you do a get from inside the this workflow. So each call zone function workflow creates its own little context to be both transactional and consistent with what you would expect from the holochain itself. And let me say that in other words. So when you call a zone function, for example, let's say that you first commit an entry. And second, you want to get the tip of your source chain, right? So, okay, you just committed an entry, but that entry has not been persisted yet because it needs to be transactional. So what this workflow does, it's creating some, I don't know how to call it, some ghost context or something like that, in which the tip of the source chain is the thing that you have just committed. Okay, so you commit entry, you go look at the first, the latest entry in your source chain, and you are going to get the entry that you just committed, as opposed to the some latest entry that you committed some other time. Okay, now if in parallel to this sum function, I'm calling another sum function, and that sum function is just getting the latest tip of the header, it's not going to see this entry that is in process of being committed. It's going to go to the source chain database and say, yeah, this is the latest thing that was produced in another time. Okay, and this is actually quite important to get if you're going to be designing and architecting holochain applications. So let's pause on this for a minute. So parallel zone calls, function calls, create mini contexts in which their own reality is what's happening on that zone function. Okay. Was I more or less clear, or are there some questions around that?
I have a question. Is
Yes.
it possible to block reading from source chain until other zone functions finish their execution?
Not, I don't think, I would think that that won't be possible on the conductor, on the cell from the backend standpoint, because this is all these workflows are running in different threads with different contexts, like it's totally different. But you can do that pretty easily, I think, from the front end. Like
okay.
you wait until this is done and then you go get.
Then second question, how do multiple threads work with the same source chain? I mean, it's shared among different threads, so it has to be guarded somehow. So how does this, how is this handled?
Right, so each zone call zone function creates a mini context in which a mini source chain is created, a ghost source chain is created, and then each of these zone functions is adding to that source chain whatever. Okay, so you can imagine the source of truth, which is the persisted source chain database, and then mini additions to that represent all the some functions that are being called in parallel. And then at the end, the call zone function workflow is going to fail if the tip of the source chain has moved from the beginning.
So
is there's a caching of sorts?
Yeah, I'm going to go to cache in a second. Yes.
Okay.
Again,
Yes.
if I want to put more light on Nastasia's question, if we go back to the traditional databases or data source, we have a topic named isolation level. It means optimistic or pessimistic. And we can select between isolation level. It means I would like to accept any consequences, let others at the same time modify or delete a record. Or you can easily, developer can say, I would like to have an isolation level as an optimistic or as a pessimistic. I would like to have that consequences. The question that do we have this kind of configuration as a data layer for isolation level?
No, we don't, and we can't. So it's all going to be pessimistic always. And why is that? Because if both two threads are committing things to the source chain, which means that they are going to be forking your source chain, because heads are in a chain. If you create two headers pointing to the same header, that's a fork. If we allow that to happen and to be like persisted, we are breaking all the security in holochain, right?
Thank you.
Yeah. Anything else on this? I'm going to go to guys now.
I wanted to clarify. So if, let's say, I have two zone functions A and B, and I start them in order A and then B, but B function ends before A function does. So it would mean that B function would be able to commit data, but then A function would fail because it finished the second.
Exactly.
Okay.
Exactly.
Okay.
And because we are on call, Nastasia, you are finished?
Yep. Yeah.
With which capability, who can call zone function, and with which capability if they are connected? It means people with the capability token which are in the Genesis can call this zone function, or anybody can call a zone function.
So this is following the capabilities model, which means that you can define, like by default, okay, any agent can only call a zone function if they have the capability to do it. If not, it's going to get rejected. Since you committed this capability grant here, you are able to call anything. If you want to here create a new capability for some agent to be called to call only half of your functions, you can commit the capability grant and they are going to be able to do that. So it's dynamic. You can create capabilities grants, create and revoke to tune that fine-grained as much as you like. Yeah.
There is no big change here. It means if a remote call is gonna be, we are gonna have a remote call as a zone function, we need to receive a capability grant token and use that one.
Exactly.
Like before version.
Yeah, but in this version, the greatest change here is that you don't define, like, if, okay, let me show this to you. Okay, so generic tags, whatever. I just want to show you a comparison. Okay, so in the past, capabilities were defined besides the function, right? So HC public would say anyone who has the capability HC public can call this. Okay, right now, this is different because, oops. Oh, okay. The capabilities are not defined besides the function. Why is that? Because you could give different capabilities to different users to call the same function.
Gotcha. Thank you.
Okay, good.
Are those layers defined at the DNA level? Like something like admin or member or? Like
No,
each agent can assign, no.
No,
Right.
because it doesn't need to. It doesn't need to know anything about that. When you create the capability, you're saying these are the functions.
Okay, got it.
Cool. Okay, so let's continue. Oh, spoilers. Okay. So cache. The same way that this new callzone function has created a mini source chain database for us, it has also created, well, it has created this cascade querying mechanism through which all the gets are going to go. Okay, and let me explain this a little bit. So this cascade querying mechanism, what it does is provide a very simple way for a get to be as performant as possible by checking progressively the different sources of data to see if the data is there. So let me give you an example. I'm executing a some function with my context, and I have a new a cascade for that. And that cascade, like let's say that in this some function I do a get with a hash. What is this cascade going to do? So first, it's going to try to fetch it from both caches in the in our source chain. Like maybe we have committed this entry before. Okay, so let's try to see if it's there. Oh, it's not. Okay, so now let's try to see if it's on the cache of the things that we have already seen in the DHT. So if you think about it, holochain, in the fact that in holochain mostly everything is content addressable, has these very powerful cache implications, in which if 10 milliseconds ago I fetched an entry with this hash, the entry cannot change, right? So I can just store it in my cache and then return it because I already have it. And there is no possibility that in the network it has changed. And if it fails, then we are going to go to the network. So in summary, it goes a little like this. Get, okay, do I have it in my private source chain? No. Do I have it in my DHT cache? No. Okay, okay. Let's go get it from the neighborhood in the DHT. And I did this because what can happen also is that you don't have it in your private source chain, but you are holding it. Like in the shard of the DHT that you are holding, there is the entry that you're trying to get. So that's a possible case also. So yeah, there is this cascade in which it's like, as a developer, you don't really have to think about it, but just know that holochain is trying to be as performant as possible and using content addressable cache. So doing a get, I don't know, a get header on something 100 times, it's going to be quite performant.
Cache always connected to the topic of expiry. What is the expire? How long it's, when it's gonna be expired, and developer can do anything regarding to expiring?
Yeah. I think this has not been settled, so the Dash hasn't settled for that yet. And what configuration options will the developer have for any options in the cell has not been decided yet. I would say that cache, so basically things that are only content addressable, is going to have quite a long expiry date. So that won't change with the network and so on. I'd say this would depend on how many entries you are getting, and you want to free space for other entries and so on. It's a different thing with cache meta, because these are links basically. So this entry had these links pointing to other entries, and that can change in the DHT. So this was one of the things that Art said to me. We have to think about the responsible strategy to do link caching, and I don't think that has been tackled yet.
But anyway, from current experience, traditional experience in the current system, we always needing this one, that if there is a caching mechanism, my experience telling me always we implemented something that telling developer can set, I know I'm gonna ask cache, but for this query or for this operation, I'm sending a key, no cache. It means I'm forcing you to do not go to the cache, go for the DHT. If we would have such sort of case, I think it would be nice. But anyway, please continue.
Yeah, let's see. Like, let's see. I don't have a good answer to the question.
I have another question about this. So when you said that you might be the node that's storing the data you're trying to get from the DHT, so you're holding this shard, does it mean that this GET request that you're making would go all the way to DHT request? I mean, you're holding the DHT shard, so it's not in your DHT cache. It's actually in the DHT. So you would be making a GET query to your node.
No. So this is the case in which I'm a validator. I'm not executing any zone function. So I'm not getting any get. I'm not doing any get, and I'm receiving a get from another node. So in that case, I will just go here and here, which is where I store my DHT shard, these three places, and look it up. If it's not there, I'm going to return none.
So when you are doing a get for something that you are storing on your side, your request also goes into these three entries that you just shown.
Yes, because we are going to see in this reactive workflow that these are the places in which they are stored.
Okay, understood.
Good. Anything else here? Okay. Okay, so just a little note on that. So in these cache databases are the essential ones because they store anything that is identified by its hash. Okay, so both your own headers from someone else, anything that is identified by its hash goes here. Why is that? Because there are no possible collisions possible. Like if you would be referencing this by, I don't know, some ID, numeric ID or something like that, you will not be able to mix this because your ID is not the same as someone else's ID. But as there is no possible collision between your headers and other people's headers, and if there is an entry collision, well, it's the same entry because it's the same hash. You're storing everything here, okay? And this provides very fast lookup on, do you have this hash? I have it or not, because I can go look at this place and that's it. As we said, cache metadata would store links, would store is this entry alive or not, would store things like that. So for this hash, I have this kind of metadata. And the source chain database stores basically a list of the hashes of your headers. So you're saying header 1, this hash, header 2, this hash. It's quite simple, actually, the source chain database, because the headers themselves are stored in the cache, right? But it's important because you need to be able to say what is the tip of my source chain and get me all the hashes of my source chain. So it's the point of entry of that. Okay, so we have another caveat with calls on function is that before returning to the UI, it's calling the app validation system and validation, not workflows, but yes, functions, before returning to be able to say, hey, you're trying to do something invalid, don't do it, please. But remember, this is in the good agent scenario, bad agent can always fork and comment that. Okay, so good agent are like any good agent that tries to commit something, it's going to get an error to the UI. Hey, you're trying to do something that it's not valid. Okay, so now let's say that the calls on function has succeeded. We have integrated because the workflows do transactionally persistence. We have persisted everything in these 3 databases. And now this workflow triggers this workflow, which means that if the conditions are met, this is called on the spot. But if the conductor dies, when the conductor boots up again, it's going to re-trigger this. So what this does is, okay, I'm responsible for maintaining what DHT operations I have authored. So everything that my actions in this application have produced, I am responsible to maintain it and maintain also, see if they are still in the network or not. I don't want to talk about this process too much, but just know that it's there. And this workflow, what it does is go to the source chain, see whatever is new, and create the DHT operations that we saw last time. So, okay, there is a new link. So let's say register agent activity, store element, and a register link. Okay, so what it does, it just gets that from here and stores the authored DHT operations here. And then it goes to sleep. That's it. Then what this triggers is the fast push published to the DHT workflow. And what the fast push is, so we are going to be talking about fast push versus slow heal. Fast push is the process by which new DHT operations are committed to the DHT as fast as possible. Because you have new DHT operations, so new things that have to happen in the DHT, you want them to happen as fast as possible. So you're going to be communicating with the validators nodes of the DHT, of all the neighborhoods of the new DHT operations, and try to reach them as fast as possible so that they can integrate, so that DHT eventual consistency is reached as fast as possible. This does not mean that it's immediate, but at least it's trying to do eventual consistency as fast as possible. And this will not only communicate with only one node in its neighborhood, it will communicate with multiple. To try, like, if I do a fast push in only one node and then that node dies, then the DHT operation is not persisted into the DHT. So I have to go to the neighborhood and do some n nodes. I don't know exactly how many. Okay, so let's now change perspective. And this has been the active node that has been calling and committing things. But now let's go to the perspective of the validator node. So a node that is receiving this fast push, which will go here. So receive puts are fast push. Some node that is receiving something like, okay, I have just committed this, please, you are a validator node because I know you're in the neighborhood, please commit this into your DHT shard. Okay, so what this node will do, it will store this in the validation limbo. So limbo is kind of a play in the words, which is we don't know if this is valid or not. So we are not going to say it's in our DHT shard yet. We just queue it for validation. Okay, and this is the only job that this does, because we need to be able to retry validation if the conductor shuts off. So what the receive fast push does is commit to the validation limbo and then trigger the validation workflows, both first system and then app validation. And system validation does all the subconscious checks that Holochain does for every entity, like the hashes are consistent, the signature is good, the headers are like your source chain has not crossed, has not forked. What else? Yeah, that's basically it. Your header sequence ID is correct. So first you did your header 0, then you did your header 1, and so on. That's basically it. And then once this is done, this gets marked into the validation limbo. So, okay, this is not yet valid, but at least the unconscious validation has passed. And now the app validation is triggered. So this is going to be calling into our application code with the DHT operations that we have received, and try to call the validation callbacks that are present into our app validation code to try to validate it. Okay, so let's say that the validation callbacks succeed. So now we can remove it from validation limbo because we have already processed it. There is no need for any more validation. And we can just say, okay, commit it into our integrated DHT operations and gas and everything, because we are now saying we are holding this in our DHT shard. And this is what this workflow does. Okay. Let's say, yeah, that's okay. I'm going to pause there and let's cover this. So I just have an overview. First part we did was push. Now we are doing pull. What happens on the other side? Go, Hedayat, go.
Nothing, just 2 points about the timing, because we are 2-3 minutes to the time, and one topic. Today we are going to finish all the workflow, or it's going to be remained also for the next week?
Like, I don't think there is enough material to do another one. And I would like we have 90% of what we need, I think.
That is fantastic. I have a strategic question that if you can, from the left side, that cover this question, that as a perspective of a developer, not architect, from a left side, which workflow a developer can have information it is enough. For example, a developer should know a good knowledge about the Genesis flow because it is required. Initialize zone, it is required. For the cache, it is not required. It's subconscious, it's telling everything. Can you do a one-time review that any developer want to receive enough information to continue implementing application, know where to go and receive knowledge?
Yes.
Thank you.
So yeah. So by any means, this has to be understood by application developers, at least in this form. I would say it's not important that the developers know about the workflows. It's important that the developers know about the consequences of the workflows, like things that we already said. Some functions have their own context, and you cannot do parallel commits, things like that, you know. Things like there is going to be a cache, but the fact that you have you do a get entry here does not guarantee that you're going to get the same result in a parallel call because there is this context. You don't have to know about the genesis function, but you do have to know about these 4 entries for headers committed. You know, it's more about that. I'd say for architects, this is really valuable because architects have to be thinking in terms of both DHT load, and the measure for that is DHT operations, and read performance, and the measure for that is DHT hops that you have to do in order to get the data you want. So that's absolutely key in the designer's perspective.
From an architecture perspective, would you say membrane control, zone function access is also improved, or is it just a minor improvement?
Okay, but this is a totally separate question than Hedayat, I guess.
Oh, okay.
So wait, Hedayat, do you have any more clarification on that?
That's it. If you covered it, because yes, thank you. Yeah. Okay.
So going back to your question, Sid, I think that the membrane proof is actually a pretty great improvement over what we have. Because you can, like previously, you really couldn't pass, for example, as a ticket with signature when you wanted to install the application. So now with that, you can, like, there is a new degree of freedom that you can use to control membranes. And that's fantastic.
And it's front, right up front.
Yeah.
And I guess the fact that capability functions are so native now, it means we can play with zone function access also a lot better. I mean, it was always there, right? Like, that's not new. It's just that it's more native.
Yeah, the thing is that in Redux, capabilities were sort of patched after building the basic things, and in here it's been built in from the get-go. Okay, so yeah, go.
Can I ask a question? Yeah, so I have 2 questions again. One, like, first of all, your diagram, the architecture, the arrows are like indicating push and pull communications generally, right? Now, this is like, if the green arrows are more kind of push communication and the blue ones are more pull communication. Is that, would you say that's make analysis?
That makes sense. In more detail, the green arrows are the workflows triggering one another. So calls and function triggers produce DHT operations. It's not the same as call. It doesn't call it. It finishes and then it says, okay, the produce DHT operation has to be executed. Conductor, do it. I'm not going to do it. And then the blue arrows are get. So from these calls and function, you're going to get the cascade. From the request data from network, you're going to get from the cascade. Yeah, that's it.
Okay, cool. The other question I had was on the capabilities functions. So if you have a zone function, you want to give a capability grant to somebody. I didn't understand whether there was any syntax change, like you remove the public decorator. Is there a decorator to indicate that it's a capability function? Like it has to, it's only, do you understand what I mean?
Yeah. So the thing to understand is that right now, all functions are capability functions. Like that's capabilities, everything has to go through capabilities. So before, what you did is, here I'm saying this function is related to this capability. So you were associating functions with capabilities at compile time. And here you're not saying that because they can be dynamically changed on runtime. So I can give you capabilities to call this function because you are the editor of whatever, and I can give Nastasia capabilities to call this function with another capability, right? Because he is the administrator. She is the, sorry, right. She's the administrator, you know? So it's not at compile time that I'm defining this function has to be called with this capability, but it's at runtime that you can dynamically say, hey, I'm creating this new capability with these functions.
Okay, if someone, because you've still got public there, if someone who doesn't have capability tries to call that function, nothing will happen.
It will get rejected for a 1.
So they get a 401 code.
Like this is WebSockets, 401 is HTTP, but essentially, yeah.
Okay. So is there any way to know in advance which functions?
By Anastasia.
Your capabilities you have at the beginning, right? You determine that information in the beginning. Yeah.
No. You like here you can call create capability grant with the functions that capability can call, that any agent with that capability can call, and then that's in your source chain. It's not in the beginning. You can say, okay, I have enough trust with you right now, so let me give you capability now.
Okay. Thanks.
One use case we're thinking of for that is when we're doing bridging.
Mm-hmm.
Bridging might happen only through trusted nodes, and so if that agent A wants to port some kind of data, they have to give capability tokens to that trusted node in that other membrane in the other DNA as well. And so capability tokens could actually be granted on the fly through this mechanism. But I'm guessing that like that's the kind of stuff it'll really simplify, I'm guessing. I'm sorry, maybe you don't need to discuss this right now. I don't know why I brought it up.
Yeah, no. Like capabilities is much more refined now, and it's like we have much more flexibility, and it's also simplified. So it's great. Like I don't like too much to use the bridging on trusted nodes because it implies remote bridging, which actually never happens. You know, so it's like it provokes some weird reaction in me. But anyway,
what do you mean?
I know what you mean.
Bridging.
Yeah, bridging is always local. So you are always bridging in your conductor from a cell to a cell. The fact that the receiving cell calls another node or anything like that, like that's something that the receiving cell has.
Yeah, but this is, I agree. And the way I frame it has to be, I agree, triggers this response of that it's actually happening across cells, which is not true.
Okay, good. So this is basically it. Like we have covered 90% of the core functionality of holochain as far as cell goes. So what I want to do is in 5 minutes give you an overview of what's happening if you zoom out a little bit, but I don't want to cover that one because I don't have too much knowledge about that, And because I think it's much less important than understanding this. So if you want to stay for 5 more minutes, we're going to have the recording for those that left to be able to see this as well. But I don't think we need a new a following session to do more core deep dive. So okay, this is it. This is more or less, if you zoom out a little bit and simplify everything a lot, this is what is happening. So we have here a conductor, okay? A conductor has a lot of cells running in it. These are the workflows that we saw in the previous diagram. And these are workflows that the conductor is doing, and these are workflows that the network is doing. Okay, first I want to focus on the cell. Okay, so like this. So the only thing that's added here is this important ribosome, I think it's pronounced, ribosome piece. The ribosome is the piece of code that actually can talk to the DNA and the HDK. Okay, remember this DNA and HDK code is WebAssembly. So the ribosome is a WebAssembly ribosome here. So it knows how to interpret and execute WASM DNA. And this is triggered by things like initialize zone, app validation, calls on function, anything from the cell workflows that has to go to the code that the application code that we have written. Yeah, and every one of these little rows is a different zone. So just so you have an idea. And then zooming out a little bit. Okay, like this, perfect. What are things that from the conductor are going to be triggering this cell? So for example, install application, clearly it's going to trigger the genesis of one cell. Calls on function, okay, so I sent a calls on function order to the conductor and it's going to find the right cell and call it. Bridge call, so for example, one piece of code here is going to ask the conductor to bridge. So it goes up to the conductor and then the conductor finds the right cell and executes the function there, things like that. And then the network is important also because it handles all the peer discovery, gossip. Okay, so for example, the cell requests fast push. So, hey, network, I have just committed this and I want you to publish it to the neighborhood, appropriate neighborhood. And the network is the one that says, okay, I know these nodes, I know these neighborhoods and so on. So let's send the message to these nodes. Things like call remote also. So here some function does a call remote. So this goes here and this gets to another conductor, right? So yeah, this is in 5 minutes, a little bit, the zoom out version. It's very, very simplified. Like I have maybe half of the workflows of the conductor and only 4 of the trillions of, not trillions, but here are maybe, I don't know, 20 workflows, 20 different workflows that the network can be doing because it can get quite complex. But just so you get an idea of the bigger picture, this is it. So I don't have any more content. So questions and things to that show up for you with there.
Sorry.
No, go ahead. I just want to say thank you for taking us through all of this.
Yeah, sure.
And I feel like all of these videos are going to make a good series. Like personally, I keep going back to them to get stuff clarified. So really appreciate it. Thanks.
Yeah, awesome. Thanks. Like in here, like I appreciate you coming. What I would say is, if you have the energy and time and so on, I think it would be really beneficial for the ecosystem that now that these videos are up and you have all this knowledge, all of you do a little bit of spreading of that also. Because then it's not me or a couple more developers, but it's the whole community that can kind of holds all this content and can be teaching others also. So that would be wonderful, I think. Thomas, you had something?
Oh yeah, just say thanks. This is really awesome. Okay, I like this diagram especially is because I really like the kind of analogy with the organism and the cells. Maybe you can even take this further and add more. Like, I didn't know the ribosome was new to me. I'd love to hear more about that. This looks like a central processing point. Yeah. So yeah, thanks, man.
Yeah, good. No, I'm glad. So the ribosome it fits the metaphor. So the ribosome in your cells is actually the one interpreting the DNA, and this is the piece of code that can interpret WASM code. So it fits quite well. In the future, if we have more compiled targets other than WASM, we will have to do other ribosomes. So let's say that this zone is written, I don't know, in like one of the reasons that WASM is good here is that a lot of languages can compile down to WASM. So the same ribosome is going to be able to interpret a lot of different languages here because they all compile down to WASM. So that's good. But I don't know, maybe in the prototype version, they had a JavaScript ribosome and a Lisp ribosome, right? So, but right now they only have WASM because that's all they need. Okay, so is there anything else? I haven't been paying attention really to the chat, but yeah, people leaving basically. Okay, great.
Or coming late.
Or coming late. Hi, Jacob. So I think this is pretty much it. So this is going to be uploaded to YouTube, and I think it's going to be a good reference series for people. In other cases, I would encourage everyone to start developing in RSM and so on, but basically all of you, almost all of you are already doing that in some form or another, or are thinking about that. So yeah, just let's keep chatting about that, and yeah, see you around. Thanks a lot for coming, and I think that's it.